Assalamualaikum warahmatullahi wabarakatuh. Chapter number 2 for Thermo number 1 is about the properties of pure substances. Okay, in terms of content, chapter 2 contents, we will learn about first about the pure substance and its phases, 2 the properties diagrams, 3 the property tables, and the last one we will discuss about the ideal gas equation of states. Pure substance and its phases. Okay, about pure substance. What is what called the meaning or the definition of pure substance? So a pure substance actually a substance that has a fixed chemical composition throughout, which means throughout any process, the chemical composition of certain substance is the same. For example, water H2O, helium He, carbon dioxide CO2, and also nitrogen N2. So a mixture of various chemical element or compound also considered as pure substance as long as the mixture is homogeneous. Okay, for example, air is considered as pure substance. For example, in the figure we have a tank consists of air, where we know that air consists of numbers of gases, type of gases such as nitrogen, CO2, oxygens, carbon dioxide, and so on. So let's say this air go through a certain type of process. Okay, so throughout the process, still the air, in terms of the composition, chemical composition still well mixed, or we call homogeneous. Okay, that's why we consider air as a pure substance. However, if we consider oil-water mixture, okay, for example, in the figure shows the oil-water in a mixture in the tank. So we have water and also the particle of oil. After a certain period of time in a process, so we call the mixture will form different type of layer, two type of layer. First, we have a layer of the oil and also the layer of the water. Okay, so now the condition of the oil-water mixture is non-homogeneous or not well mixed. Okay, in the tank. So this the oil-water mixture is not considered as the pure substance. A mixture of two or more phase of a pure substance also we consider as pure substance as long as the chemical composition of all phase is the same. Okay, for example, now if we refer to the this definition, air is not considered for certain condition is not considered as pure substance. For example, we have a container that contain air that consists of numbers of gases such as nitrogen, CO2, carbon dioxide, and also oxygen. At very extreme condition in terms of pressure and also temperature, part of the component of the air will turn into liquid. Okay, let's say the nitrogen, part of the nitrogen turn into liquid. Okay, so now we will have two type of air in terms of phase, gaseous air and also liquid air. So in terms of composition, in the liquid air is not the same as the composition in the gaseous air. So at this condition, the air is not considered as a pure substance because for different phase, each phase will have different chemical composition. However, for water, okay, let's say we have a container consists of liquid water, and we provide heat so that what I call the liquid will vaporize. So now, throughout the process, at the end we will have two type of phase. So we have vapor phase and also liquid phase. So in terms of composition, the vapor still in terms of composition is H2O, and the liquid also the composition is still H2O. So both water vapor and also liquid vapor in terms of composition is the same, which is H2O. So for different phase with same chemical composition, so the water we consider as a pure substance. Okay, now we will discuss about the phase of pure substance. Okay, what kind of phases involved for the pure substance. Okay, pure substance exists in different phases depend on the temperature and also pressure. So normally we have only three type of phase. First we have solid phase, second liquid phase, and the last one we have gas phase. Okay, so in terms of what we call explanation for the solid. Okay, so for the solid, in terms of molecule arranged in 3D patterns and small distance between molecules. So for solid, in terms of the distance between molecules very small, and the molecule are in fixed position due to the strong attraction force of molecules. And in terms of oscillation of the molecule, it depend on the temperature, where the molecule of the solid will oscillate at fixed position. Okay, example of this for the solid, copper and also iron. And the second phase of the pure substance is liquid, where for the liquid, in terms of molecule arrangement, no specific pattern, and in terms of distance, will be the liquid will have greater distance between molecules compared to solid. No fixed position due to the weaker attraction force compared to solid between the molecule, and the activities of the molecule also depend on the temperature, and the molecule will rotate and translate freely. Okay, in terms of energy of rotational movement, also translate a movement for the liquid depend on the temperature, also depend on the temperature. For example, mercury and also water. The last one is for the gas phase. So in terms of molecular arrangement, no specific pattern, and in terms of molecule, very far apart distance between the molecule compared to solid and also liquid. No fixed position because very small and weak attraction force between the molecule, between the gas molecule, and also depend on the temperature, the degree of what called randomness of the molecule also depend on the temperature, where the molecule of the gas will move randomly and collide to each others, and also collide with the walls. Okay, for example, nitrogen and also oxygen. Okay, so these are three basic phases of pure substance. Okay, now it's about phase change processes of pure substance. Okay, in order to explain the phase change process, so we need to consider TV diagram. Okay, the diagram that describe the temperature change and also the specific volume change throughout the phase change process. Okay, let's say now we consider the water. Okay, so in the table shows the different pressure with different saturated temperature. So let's say we take the pressure at 1 atm, which is also equal to 101.4, and the saturated temperature at 100 degrees Celsius. Okay, so the blue color line represent the called phase change process of the water at P pressure equal to 1 atm, which is also equal to 101.4 kilopascal. Okay, so the temperature at the horizontal line represent the saturated temperature at pressure of 1 atm. So this actually also refer to the boiling temperature for a substance at specific pressure, and the value depend on the constant pressure value. Okay, if you change the pressure value, the saturated value in terms of temperature also will change. Okay, now let's say we consider state number 1. So we have cylinder piston device contain a liquid water. The pressure is 1 atm and the temperature is 20 degrees Celsius. So we provide heat in order to increase the temperature. Okay, and the pressure is still maintained at 1 atm. So if we plot on TV diagram, this is what we call the location of state number 1. So we have temperature 20 degrees Celsius, pressure is 101.4 kilopascal, and this phase we call compressed liquid. Okay, compressed liquid, where in terms of phase, compressed liquid is 100% liquid and not vaporized. At this condition, the liquid is not vaporized. So for this phase, if we increase the heat value, so the temperature will increase. Okay, the temperature will increase, and sometimes this region also will call, instead of we call compressed liquid, sometimes we call subcooled liquid. Okay, both phase actually is the same. Okay, now we consider state number 2. Okay, let's say because we continuously supply heat, so the temperature will increase up to 100 degrees Celsius, where 100 degrees Celsius actually is the value of T saturated. Okay, so this is the location of state number 2 on the TV diagram. So this phase we call saturated liquid phase, where in terms of a phase still 100% liquid. However, at this condition, the liquid is about to vaporize. So if we add more heat, some liquid will vaporize, or some liquid will change into vapor. Okay, state number 3, the pressure is still 180 m and the temperature is 100 degrees Celsius. So at the location, at the on the horizontal line of the pressure, constant pressure line, the temperature will maintain. So during this process, the temperature will maintain due to the the change of the change of phase. So during the change of phase from liquid to vapor, the temperature will constant. So at state number 3, okay, so we will call this region or this state as saturated liquid vapor mixture phase. So we have part of the water will have vapor phase and part of the water will have liquid phase. So that's why we call saturated liquid vapor mixture. The temperature maintained at 100 degrees Celsius. So we have 2 layers of water, saturated vapor water and also saturated liquid water. So during this phase, liquid will change into vapor. And at this state number 3, if we look at the diagram, during the boiling process, in terms of percentage of vapor, still less than 50%, and the rest is liquid phase. And during the process, the value of T of temperature is constant throughout the process, and the temperature is equal to T saturated. Okay, during the boiling process, where liquid changes to vapor, we will have large volume change occur during the process. Okay, next, state number 4, still in saturated liquid vapor mixture region or phase. However, at state number 4, the process of boiling where liquid change into vapor still continue, but now at the position of state number 4, in terms of percentage, water vapor percentage will be greater than 50%, and still the temperature still remain at the constant value, which is also equal to T saturated, and also will involve large volume change during the process. Step number 5 is considered as desaturated vapor, where if you look at the schematic diagram, no liquid water available in the cylinder, 100% is saturated vapor. Okay, so at this point or at this state of saturated vapor, 100% vapor, no liquid water. And at this condition, the condition is about to condense. For example, if we reduce very small amount of heat, some of the vapor will change into liquid. Okay, that's why we call at this state it is about to condense. Okay, so if we consider the midpoint or the middle point of the horizontal line of the constant pressure line, so that midpoint actually describe the condition where 50% in terms of content, 50% consists of saturated vapor and 50% consists of saturated liquid. Okay, so the energy that provide from state number 2 to state number 5 during the boiling process or the during the saturated liquid vapor mixture region, considered as energy that absorbed during the vaporization, or we call latent heat of vaporization. Okay, for the state number 6, after the saturated vapor point, when we add more heat, now the temperature start to increase greater than 100 degrees Celsius. Okay, so after the saturated vapor point, the temperature will not constant anymore. Okay, so if we add more heat, the temperature will keep increasing. Okay, for this case, let's say the temperature is at 300 degrees Celsius. Okay, and this state or this phase we call superheated vapor phase or region or point. Okay, if we add heat, vapor temperature will increase, the superheated vapor volume also will increase. And at this point, although at this region or at this phase, although we reduce the heat, so the what we call the superheated vapor or water vapor will not condense because the point is far from the saturated vapor point. So these are the phase change processes of the pure substance. So in this example is for water. So the concept still can be applied for the different type of substance.